Hello everyone. So let's practice some examples related to deterministic finite automata. For example, let's say language L1, set of all strings which have length exactly 2. Okay, so I want to form the language which contains the 2 length string, and all the examples in later I have give you some examples. In all the examples, assume that the alphabet in the language, alphabet means sigma in the language will be small a comma small b. Okay, so using a and b, what are the possible strings which have length exactly 2? The possible strings will be AA, AB, BA and BB. Okay, so let's draw the DFA for this language. So the DFA will be, I have to start with the initial state. Let's call it A. If I see a alphabet A or B, I will go to next state, capital B. So here on small a, I have not seen anything, but on capital B, I have seen either 1A or either 1B. Now I want to trace one more A or B for achieving the length of exactly 2. Okay, so what I will do here is, I will take one more transition A comma B and go to a final state, capital C. Okay, so this is over or something remain? What on capital A, I have shown the input A and B as well. On capital B, I have shown the input A and B. But what about the final state, capital C? If you see a symbol A or B on final state, then you will go to some state called dead state. Okay, so this is our minimal DFA for this language. So in all the examples, I will give you minimal DFA. Remember that there are many ways you can draw a DFA for any language, for such a language, but the minimal DFA will always be unique. Okay, so how can I draw this particular DFA? You always start with the initial state. After seeing some input, you will go to some other state. Okay, and this is accepting one length string, and then accepting one more length string, you will take one more transition, and then after for final state, you will go some dead state. Okay, let's take one more example. Let's say language L2, which is set of all strings which have length greater than or equal to 2. Okay, so I want to form a language L2 such that the length is greater than or equal to 2. So what are the possible strings? The possible string will be AA, AB. Why I will take 2 length string? Because it will say here the length may be equal to 2 and greater than 2. So AA, AB, BA and BB. This is 2 length string, and after that I can accept more than 2 length strings. So the possible string will be also AAA, ABA and so on. That means this language is infinite language. Okay, so the DFA will be, let's say I will start with initial state capital A. On seeing small a or small b, I will go to state capital B. On seeing small a or small b, I will go to state capital C, which is final state. And on final state, if I see any number of A's or B, I will simply accept it. That means in this DFA, there is no dead state. Okay. On capital A, if you see a small a or a small b, that means one length string is accepted. On capital B, if you see a small b, that means you will accept two length string. And on capital C, you will accept any number of string by just taking a loop over the capital C final state. Okay. Now language L3. Let's say language L3 is set of all strings which have length less than or equal to 2. Less than or equal to 2. So in the previous example L2, I have taken a language which contains the length greater than or equal to 2. Now in this example, I have taken a language which takes length less than or equal to 2. So what are the possible string? Possible string will be, so here you can simulate that the language L2 is nothing but taking at least 2 length string, but language L3 is taking at most 2 length string. Okay, so here it is at least, and here the concept is at most. So the possible strings in this language will be epsilon. Epsilon is 0 length string. Then single length string will be A and B, and then 2 length string will be AA, AB, BA and BB. Okay, can you draw the DFA for this language? So if you want to accept epsilon in any DFA or NDFA, then you can make initial state as a final state. That is the only way you can accept the epsilon in the language. Okay, so if I take a DFA, let's say small a is the initial state, then if I want to accept epsilon in the language, then I will make this small capital A as a final state also. So capital A is initial as well as final state. Now if I see a small a or a small b, I will go to state capital B. Capital B is also final state. Why? Because it is saying that it accepts one length string also. Okay, so for epsilon, I will make capital A as an initial final state. For A and B, I will make capital B as a initial and final state. And for length 2, AA, AB, BA and BB, I will make capital C as a final state. And what about the length greater than 2? I will not accept. So for length greater than 2, I will simply reject the string. So for rejecting a string, you will go to a dead state. Let's say dead state will be capital D. So capital D is not a final state, it is a dead state. Okay, so this is the DFA for language L3. So if I generalize a formula for such type of language, let's say here language L1 is L1 language contain exactly 2 means n length string. If you have given n length string, then what will be the number of states possible in this language? If I have given you a language which have exactly n length, then what is the total number of states possible? The total number of states you can easily count here. For 2 length string, How many number of states present? 1, 2, 3, 4. Total 4 length present. Means for n length string, the total number of states possible will be n plus 2. So remember this. This will be very important for GATE exam. For length L greater than or equal to 2. For length greater than or equal to, say, let's say for length greater than or equal to n. Okay, then what will be the number of states? Number of states will be, count here, 1, 2, 3. So there are total 3 states present for length greater than or equal to 2. So what about length greater than or equal to n? It is n plus 1. And for length less than or equal to 2, the total number of states present is 1, 2, 3, 4. So for length L less than or equal to n, the number of states is equal to n plus 2. Okay, so you can generalize that way so that it will be easier for you to recognize such languages in the exam. Okay, so in the next video we will see some other examples related to DFA.